Okay. Hi student. Welcome to Learn Chemistry with Emerald, and we are going to be talking about the scientific method. The scientific method. Let's define the scientific method. It's a logical, systematic approach to solving problems. In a simple, in a simple term, the scientific method is a logical, systematic approach to solving problems. Now, how do we start with this scientific method? Like we have said, we start with a problem. In science, scientists are inquisitive, are curious about things that happen in their surrounding. So, a problem to be solved usually starts with a question, and the question is why this, why that. Why is it that when you throw a ball upward, it falls back? Why is it that when you light a match on the paper, everything burns? Why is it that when you add petrol, the fire burns faster? So these are questions that hold in the minds of scientists. So once they are able to ask this question, then of course they begin to make necessary curious attempt to answer those questions. So to solve a problem, a problem starts with a question. And once the question is stated, the next thing is observation. Scientists use their senses to obtain information about the problem. They use their senses to obtain information about the problem. So they begin to observe, they begin to observe, they begin to observe. Now, after observing, the next thing is they propose an explanation for their observation. They propose an explanation for their observation. We call that one hypothesis. So, in the scientific method, that it starts with a problem, and the problem starts with asking the right questions. Then after that, begin to use your senses to provide information about the problem. That's observation. After observation, you propose an explanation for the observation. We call that hypothesis. Now, after hypothesis, you begin to carry out various experiments. You test your hypothesis. That means that how do you test your hypothesis? Um, you can have a manipulated or independent variable, a variable you can change, and then you have a responding or dependent variable, a variable you observe. So in experiment generally, usually you have controlled experiment and then of course variable experiment. So or variable factors and control factors. Now what do you do? Why do you do this? Because you have to change when you have to change different variables. For instance, if you are carrying out experiment on a particular thing, you may want to change the temperature, want to change the pressure, want to change the volume, want to change the size, want to change the color, want to change the position, etc. So this variable that you can change, they are called independent variable. They help you to know. They give you information about effects of all of these variables on what you are doing. Now immediately you change the you have a variable independent variable the same way you have a dependent variable doing an experiment, and that dependent variable uh, you observe what happens from the independent variable that you have done. So you observe the dependent variable, but it varies the independent variable. Now after saying that, immediately you um, conclude with your experiment, then you make a conclusion. From the experiment, you make a conclusion. You analyze experimental results to form theories or law. So a typical um, conclusion will either result to a theory or law. However, please note that um, for theories, for theories, when you have explained and tested your hypothesis very well, it leads to a theory. You have tried to explain why, and then of course to some reasonable extent, uh, based on available resources at that time, it leads to a theory. However, the difference between a theory and a law is that a law is a statement of fact that has been proven beyond reasonable doubt. A law, so in terms of hierarchy, when you immediately after hypothesis has been tested, and of course all the experimental data corroborate, you have a theory. However, theories can be modified or changed because theories are written or theories are stated based on available facts at that time, or based on available information or available condition at that time. So theories can be manipulated, but before a theory becomes a law, before a theory becomes a law, that means the theory has been from hypothesis to theory. Then the theories now have been proven without reasonable doubt, without any contradictions. Then it becomes a law. So a law is a concise statement that summarizes results of many observations. A law is a concise statement that summarizes results of many observations. Um, Sometimes a law can also be called principle. Please take note of that. You can have a law or a principle. You can have a law or principle. Now, may I also state that sometimes the sometimes um, the concept you are trying to pass on is an abstract concept. When we say abstract concept, that means it cannot be um, explained because it doesn't make sense to the common brain. So we use a model for an abstract concept so that we can understand an abstract concept, something we cannot see, something we cannot feel, something we cannot easily understand. So a model is used. So a model is a pictorial representation of abstract concepts. A model is a pictorial representation of abstract concepts. So that is a model. So in a typical scientific method, it's possible you have an hypothesis. Hypothesis are just explanation of some of the things that you've observed. However, where you have tested an hypothesis with experiments and you have reached conclusion based on available data, you have a theory. Of course, like I've said, a theory can be modified because it's just a statement of fact you have at that time. Okay, and that is why as you are learning chemistry, you are going to have hypothesis. You are going to learn more about hypothesis. You are going to learn more even about theories. For instance, we have the Dalton's atomic theory. Dalton postulated a theory on atom, and then he gave various theories. However, because at that time that was what was obtainable, the theory was accepted. However, the theory was modified based on new developments. Some of his theory, he was talking about the indivisibility of atom. Okay, but later on, it was proven that atoms can be subdivided into three main parts: the proton, the neutron, and the electron. So that negates what you have said. So the theory was modified. However, if it was before it became a law, and that is why you start with a theory, and those law that you have seen, the gas law, the Boyle's law, the Charles law, all the gas laws, um, the Le Chatelier's principle, etc. They are not a theory again because they have been proven without reasonable doubt that and it stands, no changes again. no changes can occur. It is at the theory level that modifications and changes can occur. One becomes a law, that means it has been proven beyond reasonable doubt. Of course, in terms of model now, I know you'd have heard of or later on you'll be hearing about the Neighbor atomic model, the Ernest Rutherford atomic model. Now, atoms are something we cannot see with our naked eye. So, in order to explain what an atom is, so they begin to use a model to represent an atom. So, those are some of the things that you need to know. Like we have said, model are representation of object or system. Okay, so what have we said so far? In the scientific method, you state the problem by asking question. You gather information through observations. You gather information through observation. Then you form a hypothesis. After forming hypothesis, you test the hypothesis with experiment. You analyze data. Of course, in an experiment, you have an independent variable and a dependent variable. So, and from your answer from the experiment that you have tested, you analyze the data that you have that you have gotten. Then you draw a conclusion. If the hypothesis support your conclusion, then you have a theory at hand. But if it does not support your conclusion, you go back to modify your hypothesis. Now, if the hypothesis support your conclusion, you test it again. Then you test it over time. So immediately you are testing it, and then it has been proven without that, within the limited resources and available evidence at that time, it becomes a theory. Then once the theory has now been fully tested over time, and then it has been proven by scientists from everywhere without reasonable doubt, then it becomes a law or a principle. It becomes a law or a principle. So all this method, all this systemic and logical manner by which you draw a conclusion is called the scientific method. So in the scientific method, to cut it short, it starts with a purpose by stating the result, the problem, then go on to research by finding out about the topic, then hypothesis by predicting the outcome of the problem, then experiment by developing a procedure to test the hypothesis, then analysis by recording the results of the experiment, then conclusion by comparing the hypothesis with experimental conclusion. So all this method, all this manner, all this way that you go through in order to arrive a conclusion, in order to state a particular problem, is called the scientific method. I hope you have learned one or two things about scientific method now. Um, in the next class, we are going to talk about the scientific measurement. How do you measure in a science experiment, or in science, or in chemistry generally? You need to know how to measure, because you are going to need them when you are doing your scientific methods. Bye bye. Continue to learn chemistry.